Hello everybody. My name is Rony. I come from Happy Elements. So we are a social game developer in China, but now no one is talking about social game right now. Everybody is talking about mobile, and we have more than 600 employees around the globe. We have branch office in Shanghai and Kyoto in Japan, and our headquarters is based in Beijing. Today I'm going to share with you guys about our mobile 2D framework we've been working on for a long time. And actually, this presentation is very, very technical. And the IP actually belongs to our CTO, so I will try my best to make everything clear. Please forgive me if I fail to do so, or I use some wrong terminology. Okay. There are many whys in this speech today, and I'm going to talk about being a developer, why we choose to stay in the Cocos2d-x engine by that time. And after that, we will talk about our overall structure design of our own framework we've been working on. So first of all, why we choose Cocos2dx. We have used many techniques or engines in the past years when developing mobile games. We developed our own first mobile game, Happy Fish, on iOS in 2011. It took us 6 months and finished it in the next April. So at that time, we chose to use Cocos2d iPhone, which cost us some effort on porting work on Android afterwards. Then we chose HTML5. There was no Cocos2d HTML5 at that time, so otherwise we might succeed already. And before we used Cocos2dx, we had tried many other techniques, such as Adobe Air porting as well. After using Cocos2dx, we tried another engine, Conora, before most of the others in this industry, simply because we thought this language is controllable. And we have tried Unity too. And we're still working on a Unity project recently. And as there are so many engines or techniques on the market, why we have chosen Cocos2dx as our framework? So there are several reasons. The first of all, it is cross-platform. And we can see that the Android market is actually larger than the iOS market, especially in China. And it's getting larger than iOS in Korea, so that's Japan. So Android market is probably larger than iOS in most of places around the world, besides Europe and America. So cross-platform is a must under this situation. Secondly, the performance. Actually, the performance of Adobe Air and HTML5 were relatively very poor. We had a game called My Kingdom. This is a PC game already, so we want to port the game to iOS by Adobe porting. But we had to cut off nearly all the animations for smooth game experience, so this is very terrible. The performance of the HTML5 was also not satisfying as well at the time. And finally, controllability. So it has to be controllable when we are making technical plan. While using Adobe Air porting years ago, we found that we can hardly do optimization. We cannot control its performance. We can't get SDK connected when we were trying to do some optimization on some local market or platform in China. And the controllability was really bad. So based on above reasons, we have chosen Cocos2dx. This is an open source framework, and the performance is good, and it is cross-platform as well. And based on Cocos2dx, we are using scripting language in our framework. So why we do so, this actually comes with blood and tears. Okay, so let's talk about update. Google Play is a very open platform. You can do almost everything, whatever you want, either updating code or material resources on Google Play. Moreover, it is very quick. You can update everything besides class within 2 hours update, right? And but it takes 5 days to update it on the iOS, and you have to wait probably 2 weeks for approval. So the update cycle is very long on iOS. Another thing is that the multi-version maintenance problem. It'll come to a multi-version maintenance problem if you need to get through the approval process, and because some of the people they hate to update their games. So a lot of the players will click no when they see the update notifications. Our CTO has had more than 100 updates waiting for him on iPhone and even more on Android. So multi-version will be a big problem in this situation, especially for online games. And our iOS game, Happy Fish, with a very early game, had to maintain 7 or 8 different versions, so which consumed a lot of resource to do that. And another thing is that you cannot do incremental, update on iOS and some local Android markets. So Google Play can do so, such as if you want to update your Soul file directly, but not the others, it only downloads your update files, and this is an incremental updates. However, if you have to download everything again, you have download everything again when you want to update on iOS, right? And some other local Android market in China. So it caused a big trouble for many of the players. And we also have, we have big packs and small packs internally with our own packaging tools. So the small packs only contain those required for the first time running. And big packs contain everything needed in a single APK or IPA file, including every resolution it may need it. So in this case, containing all resolutions could make the pack really big. If you want to support as many different devices as possible with your APK, your file size will be times larger than supporting only one device. So does the bandwidth needed. And debugging is rather difficult too, and the debugging tools are really different. So we usually develop our games with a super debugger. This is internally, name. It is a tool we developed based on an open source project. I will mention it later. But it doesn't mean that your program will work well on iOS and Android. Resource calling, all kind of function calling may cause crashes. So it is still necessary to use C++ to debug. And during the debug process, we found that variables of context usually change. The debug value of the shown value is also wrong, and yet I don't know it is because of ARM or something else. And another thing is device debugging, which is troublesome as well. You have to use Mac to compile, deploy, and debug for iOS programs. But the thing is that not everyone is familiar with Mac OS. Most of developers do their work with Windows system, right? If you want to use C++ to develop games on Android, the thing you have to do are compile, deploy, and debug all using scripts. We have many scripts for Android developing. And the NDK supported in Eclipse these days, but however, it's not good enough, especially debugging. And this part we'll talk about crash. So there is another C++ program crash. We almost spend our 50% of our debugging time dealing with crash. With our own quality standard, we only allow 5% crash rate over 5,000 minutes testing sessions. So one reason for crash is that auto-release pool we are using in C++. So it is very hard to find the crash source while something goes wrong with things related to auto-release. So we have to go over everything again to find the problems. And also, context and stack are usually lost in optimized mode. So as we all know, it always happens. So based on these reasons, we are trying to create a stable C++ framework so that our developers can code as less C++ as possible in the future to avoid annoying crash problems. And there are many, scripting languages in the market. Why we choose Lua in our framework? So the reason is very simple. Because the source code of Lua is short and useful. The source code is around 500K. It is very transparent and controllable. And we can change, almost everything directly as you want. So Lua is also very lightweight, which you can use on many things, and that is quite useful. And another reason is that the the Cocos2dx plus Lua technology is the most mature solution we can see in the local Android market in China. So these are reasons why we choose Lua. Okay, and afterwards I will like to tell you what we have improved based on the Cocos2d plus Lua framework. Okay, so the time when we choose Cocos2dx plus Lua, we were probably using the old version, as we didn't have the Cocos Studio by that time, and we have to do a lot of works by ourselves. The first, we have developed third-party library integration API, and we all know Lua, Objective-C, and Java should work quite smooth together. So one of the key factors of Lua Java is call function between each other. So it is very convenient in either ways. So we made an integration of Lua and Java. And another colleague in our company made an integration of Objective-C a few weeks ago, and it works really well. And we also replaced Lua 5.1 with Lua JIT and improved its performance by 5 to 6 times. Yeah, which is really impressive. And we have developed a lot of our own tools. So the first one is IDE. We believe that many Lua developers have used IDE as a debugger. So we think it is necessary to develop an IDE, as we can have many programmers start, Flash, and it's difficult for them to do coding without IDE. And another thing is debugger. We have talked with many people in this industry, so we still feel that we need a debugger which can output variables, set breakpoints, and do trackings. Okay, so we redeveloped a debugger and changed it to IDE plus debugger. And we didn't have Cocos Studio or Cocos Builder by that time, so we developed an UI editor based on an open source project as well. And we put an open source plugin in CS5 and use it as our UI and animation editor. We also developed a TTF font export tool. TTF font is usually involved in our games development. You will need a lot of storage to fit the whole font pack. That could be 5 to 6 megabytes, right? And you might actually need only 20 or 200 of them. 200 out of 6,000, which is only 130, right? So as everyone knows, if you put a font pack of 5 mega into the Android game, it could enlarge the file size a lot. So using TTF can help you to pick out the font you need and throw those you don't need away. Okay, so this part we'll talk about our framework. So the base is Cocos2dx, and we mainly work on some aspect on Android, including rendering. Then is a localization. For example, you may need different materials and files and language for different regions. And I'll talk about the resource management later, which is a very complicated framework. I think much more complicated than the Cocos2dx resource management. And here comes the utilities. Our utilities mainly have 2 parts. One of them is a configuration manager supporting C, Java, and Lua at the same time. Another one is external environments, including version and device management, also apply with Java, C, and Lua. And the next is the network library. Our network library is based on CURL. In addition, we have our own scripting engine extensions. Like I have mentioned, we integrate a lot of interface into this engine. And we are more excited about the crash analysis we have built in our internally. We have our own crash analysis system, so we collect the user's crash and carry out analysis. We put them in a stack order, and we find crash which happens most frequently. And no need to talk about the log management. And the last one is the memory disambiguation. So the third-party integration, we might not to do it if we have plug X at that time. But I think the plugin X API interface remains questionable. For example, there are many API when you integrate with Facebook. but there, faithful iteration is also very fast. But if you have to keep using the unified API of plugin X, you may not be able to connect to many useful APIs, offered by Facebook. So we actually meet a bunch of API interface, including API of different local markets and social networkings, such as 91 in China, UC Web in China, and the API also including payments, notifications, our own data mining, data logging system, and our own cross-promoting wall and logger tracker CI service as well. So all of them made up the third-party integration library. And next, the developed tools, including IDE, debugger, automated build script, and packaging tools. Most of people think Android is more difficult than iOS to debug, but actually we think it is much easier. So you can change almost everything, right? Including changing the source file directly if you want. So we have a lot of scripts about Android debugging to help us, to do develop. And we have just talked about a very important framework, which is the extension of our script engine. So with this extension, we can handle all the interface of Cocos2dx and our own interface, even iOS API and other third-party APIs, without using C++, but only Lua. But other developers still need some work on C++ to use Cocos2dx. And we also develop our own Lua debugger based on an open source project. We internally call it Super Debugger. So with this debugger, we can set breakpoints as you want. It supports device debugging now, and it's used on all of our recent projects. This debugger is based on Zero Brain, of which the debugging performance is very low, mainly because the principle of Lua debugging is that you have to call this out for each execute every time. It means that you have to call out a complicated debugging line with each execute. So we have made an improvement by setting the breakpoint to C layer, and we use C to filter breakpoint and improve its performance by 120 times. I think, our CTO told me that this makes our debugger, Lua debugger, probably the fastest Lua debugger in the world. And in addition, our improvement supports our own symbols and quick locate of the file. Another function is to push to device. I will talk about it later. We can push the device directly and push the changed code easily. And our debugger also, with improved context helper, now supports smart tips also, which will help you to do the debugging. And what is the principle of push to device? I think we made we made stuff for iOS and Android and tell which file is changed. Next, the debugger pushes the file and closes the connection. So this is the process of the push to device. And debugging is done active connection from the sub. And after the connection is successful, instructions will be sent, and with logs and breakpoint sending back. Debugger will be informed when it encounters the breakpoint, right? So this is the main principle of push to device. And now let's talk about the resource manager. We have worked on this resource manager for a long time. We had to ensure that we make complete transaction for every update, right? And we need incremental updates instead of downloading the whole package again. And then we need to download on demand, right? Which mainly means download by modules and by matching the resolutions. And we have to support resource encryption together with description. And especially for Chinese market, any other things need to be done is APK update, because there is no way to download in many markets, to download your game in many markets. So update of the APK is necessary. And these are the main content of resource management design. We have a resource locator version, and then we may have a lot of resource locator, and then the APK app directory. Yeah, this is the resource manager design in our company. Okay, so let's talk about incremental update. first, the client asks dynamic server to fetch the latest configuration. Then the client will check locally whether the current configuration is up to date. If not, then go to download the latest configuration from the CDN. After updating the latest configuration, the client will check over required resource for the latest configuration. Then the missing resource will be downloaded before getting to the games. So this is the structural process of our incremental update. And what is download on demand? I believe most of you guys know that. So there is a interface to make sure all modules are available, and check the local cache to see if they are available and download the resource if necessary. And then call back directly if it doesn't have to update, and then load the resource after callback. So this is really very simple. Okay, and the crash analysis system, one is reporter and another one is a brick pack. So there will be a task after the user has agreed. It is a thread and is thrown into crash analyst center, and it will be thrown back in center of symbol we have been compiled before. And finally, a log tracker. So our developers can see all files, users, account information, payment information, and the amount of crashes through the latest log tracker. So this is our complete crash analysis structure. And next, let's talk about the build. We have developed a build management system. It is mainly developed with Hudson. It supports download and install on mobile devices. What is download and install on mobile devices? It means that I can download this IPA or APK file directly by visiting a website with my phone. Another thing is the update notice of new version. Player can see a notice telling him that a new version is available, and the update package will be automatically downloaded and installed after user confirmation. So this is one of the main functions of our building system. Then the analysis of crashing and log collection system, and the analysis of the session time. We need to know how much time needed for our tester to do testing as an important indicator. And our crash analyze is also based on analysis of session time. And we'll skip the CDN check. It's very simple. And the next one is the UDID management. So there is a UDID problem on iOS. Maybe everyone knows that. If you're not on the list, when you then you cannot download the app. So we always find that our tester cannot download the application caused by UDID problem. And now we are working on the one-click submit to App Store and Google Play. So the job is undertaking, and I believe that we will finish that in the near future. Okay. And this page is about our build CI framework. As we can see that our build management system has done a lot of things, including generating API, generating IPA, generating APK file, downloaded files, and packaging. So the basic modules here, the blue parts, are parts basically done by us, by our own. Okay. And afterwards, we'll talk about our tools. So including, we're using different kind of tools. I will mention two of them, including Dragon Bones. We have changed the engine to support, the required format in our company. Then we use font editor also. And there are a lot of third-party tools. We use both particle designer and a glyph designer. Okay, so finally, I'd like to thank to the open source project, especially Cocos2dx. We can develop our own games more quickly, in this bloody market. Okay, and this are Cocos2dx, Lua Java, Wax, and Zero Brain, Mob Debug, Dragon Bones. Okay, so that is mainly of our speech of our 2D mobile framework. So there are a lot of details in this framework. So because of time It's short. I may not make everything clear. And another thing is that the IP belongs to our CTO. So I'm not a, I was a very bad programmer years ago, so I became a product manager. And unfortunately, I will not open any question for you guys. If you guys want to have any further questions, you can send an email directly to our CTO. His name is Ling Cong. The email is cong.ling@happylimps.com. And if you guys are using WeChat, you can edit the WeChat account directly. It's a Cong_Ling. The last is 1. It's number 1. Okay. So if you guys have further questions, feel free to contact him directly. Okay. Thank you guys very much.